Hi everyone, let's start with this problem. This is an easy problem. It's about centroids. Let's start with this simple example. It says for each image, label the size and moment arm of the differential slice and substitute into the appropriate centroidal equations. Okay, let's start with our equations. X bar, it's equal, and actually it's a ratio. It's the integral of my x tilde dA, and this is my area, obviously with the corresponding boundary. And later, my second part is my differential of area. The other equation is y bar, that's equal to this division, and now instead x tilde, it's y tilde, and the differential of the area again. And the area, it's again in this equation. The picture is showing me the shape. It's a parabolic equation. This is the shape. My equation is x equal to y squared, or y squared equal to x, same. So my first step is to propose the position of my slice. Okay, remember that I will have an strategical points to identify. For example, here, this point is the intersection my shape and my slice. This point is x, y. My local centroid is this point, and actually it is x tilde and y tilde. So once that we know that positions, these locations, let's check what is the size of my slice, because I will calculate the complete area of my shape using this infinitesimal slice. So my distance for this position is my length. This length is equal to the location of my x tilde, but actually it's in the same position that we have x. They are exactly at the same position. On the other hand, high is my y tilde, and since it is at the middle of this high, it's equal to my y over 2. It's the complete y, so the middle is y over 2. So now, what is the dimension of the base of my slice? Okay, remember this is an infinitesimal dimension, so this is my dx. Now, the next step is to go back to my equations and to start to calculate what is needed. For example, my dA. We know that my area, the area, remember that dA is the area of my slice, is dA, it's equal my height I will take the height of a general slice, not the biggest one, because obviously the biggest one goes here to the right. But since I will take different slices from the left until my bound, so I need to represent all the heights. In this case, all the heights can be represented by the height that comes from y. And my base of that rectangle is the x. If I take my first equation, x bar it's equal to my first integral here, x tilde, and my differential of area is y differential of x my part of this equation is directly the differential, so it's y dx. Okay, so on the other hand I can start selecting my boundary. So this is from 0, I'm running on x, to 4. So here 0 to 4, and the same here 0. But well, we know that it's not possible to calculate its integrals because we have more variables. We need to have everything in function of the same x. So it could be equal to, again, let's do it here, my first integral, 0 to 4, my x tilde, it's equal to my x. So it's in terms of x, so here I will substitute instead x tilde my x. And later the y. The y, I don't have directly the y, but I can take it from this equation. So my y is equal to x to the half order. So if I substitute here instead the y is x to the 1/2 differential of x. And the same, well, and here is the same. And here I need to replace again, so it says x 1/2 differential of x. So this is my equation so far. The next is algebra. It's equal to my integral 0 to 4 x 2/2. I'm just converting to have the same x 1/2 dx 0 to 4 x 1/2 dx. Okay, this is the product. So my integral from 0 to 4 x over 2 differential of x, integral 0 to 4 4 x half differential of x. Okay, so this is my first equation, my x bar. But now let's check with the second equation. My y bar, this is equal to, now integral, so it's y tilde times dA, and here dA. Now this is equal to, I need to replace here my integral of y tilde, and y tilde it's equal to y over 2 dA, and again dA here. So this is equal to my integral, but let's see what happened with the dA. I'm just copying I'm just copying the first part of my equation. My dA is y dx, and here again y dx. Again, in this integral I can't continue because it's not possible to calculate the integral of y in function of x here. So we need to replace this y, all the y's here, by my numbers that I have here from my equation. So my integral is y is equal to x to the half we have here over 2, so it's over 2, and later again the y, but y is x to the half x. Now here is x to the half. So from here it's equal to 1/2 of the integral of x dx the integral of x 1/2 dx. Okay, what happened with the bounds? My boundary in this case is in function of x. We are running from 0 to 4 again because it's my differential, so it's 0 to 4 and 0 to 4. My solution here for the equation with y tilde is this one. And that is all, guys.